understanding, remember yesterday we made this connection that really, another way of looking at the integral, it's just what? The antiderivative. So in a sense, if I say that inside the integral, let's say f of x dx, right? What does this represent? If I take the integral of f prime, what do I get? I get f of x, right? Because the derivative and the integral cancel each other out, right? Now, let's go through the units of things. If I give you position, what units is position usually? What kind of, what? Oh, they said something American. Okay, feet or miles or meters, right? If I give you, then the derivative of that would be velocity. That would be what units there? Feet per second, miles per hour, and so on, right? Whatever. Okay, are you guys okay with that? Okay. Let's talk about like the amount of flies in a jar, right? Let's say f of t represents the amount of flies in the jar. What would the units be on this?
Flies.
Number of flies. How do you spell flies?
Oh my, you spelled it wrong. It's not
I just asked you, is that how you spell flies? Flies? All right, no? Okay. All right, so f is the number of flies. Therefore, the units for flies would be, for f of t would be the number of flies, right? That's easy. What would f prime then be? This would be the rate. Let's see. This is the rate at which what?
Flies are entering a jar.
Yeah. Or the rate of change, right? The rate at which the number of flies is changing. You guys okay with that? Right? Because f prime is always rate. What's the units on that?
Flies per second.
Yeah, flies per second, I guess. Okay. Let's do this. Over t seconds. So that way it gives you everything. All right? Are you guys okay with that? Those two things. Okay. So f prime represents the rate. Now, what if I go backwards? What if I tell you that this is, instead of f prime, it's r of t? R of t is the rate at which the flies is changing. All right? Flies per hour, flies per minute, or whatever, flies per second. Then how would I get back to the number of flies? What would I have to do? This would be the integral of r of t, dt. You guys follow me there? Okay? So if I give you a rate, how do you figure out kind of an amount? You take the integral. You guys okay with that? Okay. So that's what's kind of happening here. Just the simple integral doesn't really give you the amount, the number of flies in the jar. What it gives you is the change of the amount of flies. So if there was, let's say I got the integral from 5 to 10 of r of t dt. This is an amount, so the units would be what? In this context, what would the units be? Flies. But it's not the amount of flies in the jar, it's the amount at which, or sorry, I should rephrase it. The amount of flies that have been added or subtracted over this interval, right? If there was 10 flies, let's say there were 10 flies when t equals 5. Okay? And let's say the integral is 20. What would that mean? That means 20 flies were what? Added to the jar over this interval, right? So this means 20 flies added. Then what else does that imply?
That flies are going in.
Therefore, how many flies are in the jar? What?
20, 30, wait.
Oh, 30, you're right. I'm looking at that number. There are 20 flies added. There were 10 at t equals 5 at the beginning. Therefore, there are 30 flies in the jar. When? When t equals what? 10. There are 10 flies when t equals 5. Then we added 20 over this time interval. That means there are 30 flies at t equals 10. You guys okay with that? The interval gives you the amount of change. It doesn't give you a rate, it gives you an amount of change. Okay? So we go to this problem, and the rate is given. So I think they use the same variables here. Okay. So the rate equals t cubed minus 4t squared plus 6. First thing I need to do is figure out when the altitude is decreasing. The altitude decreases when the rate or the derivative of altitude is negative. So what is the derivative of altitude? It's the rate, right? So when is this negative?
1.572.
I'll do this. I guess I'm going to show all the work here. I'm going to set this equal to 0. And that's t equals a lot, right? But we're only looking at this time domain. So what is it? 1 point what was it? 572.
And 3.514.
Okay, and then if I was going to do a number line, we would start at 0, 1.572, 3.514, and then 8. And this is positive, negative, positive.
Yeah.
Okay, so we would say the balloons altitude is decreasing. What? 1.572 less than t less than 3.514. You guys okay with that? Okay, so that's the first thing. Now I need to figure out how much it's decreasing by. So how do you figure out the amount that it changes based on what we just talked about? You take the integral of what? A rate. So it's the integral of r of t dt, and we wanted to know the change of altitude over only this domain. So the lower limit is 1.572, the upper limit is 3.514. So the answer is what? A? Yeah, notice it's not r, it's r prime, or sorry, it's not r prime, it's r, because r is already, r is not r prime, but r is already a what? It's already the rate. It's already kind of the derivative, in a sense. Does that make sense? So r prime is like the what? It's kind of like the acceleration. That's not what it is. Okay, so did I say that this one's only worth 1 point? I did. See that? I've got things planned out to the T. It's about time.